Welcome to the Mind of STEM, where you get your daily dose of science, technology, engineering, and math. I'm your host, Leon Jones. Now, in this segment, I'm going to talk about the software used in architecture, engineering, and construction. Now, there is some overlap between the three because they are related. And when it comes to the bottom line, you have to know about estimating, you have to know about planning, you have to know about design. But what sets these three areas apart on a different scale is each and every component of software that goes into designing a building is also different. Let's take architecture. Architects use Autocad. Autocad is the most popular software here in America. Now, with Autocad, you get architectural designs. Autocad is basically very specific. Comes in 2D and 3D. And with AutoCAD Architect, there's also AutoCAD MEP, which stands for Mechanical, Electrical, and Plumbing. And that goes under architecture because you're dealing with buildings. Now there's also SolidWorks. There's BIM, known as Building Information Modeling. That's relatively new. There's also architecture rendering, which you deal with Chief Architect and SolidWorks. Now moving on over to engineering, if you're on a mechanical side, for the most part, you're going to use Inventor. Now, Inventor is a software that's designed to go from 2D to 3D. Now, basically, when you use Inventor, you're creating parts such as bearings, gears. You're utilizing Inventor for brackets. Again, you start off in a 2D fashion and you go to a 3D fashion. Now, I believe Inventor is a little easier than AutoCAD because Inventor, you don't have to be as specific with your dimensions because with Inventor, you're creating a prototype. And a prototype is a drawing that you are going to utilize for testing purposes to see if the drawing, the specifications, the testing of the prototype all work with one another, or let's say pass muster, so you create the final design to launch a new product. Now, there are other mechanical softwares out there, but the main one again is made by Autodesk. And when you deal with mechanical engineering, there's also BIM for mechanical engineering, building information modeling. Now, mechanicals use BIM when they design heating, ventilation, and air conditioning systems, primarily on a commercial side. They do a little with the residential, but when it comes to commercial, you have to get more in the heat loss and gain. You have to deal with how many rooms you have in the building. You deal with zoning systems. That's another topic. Now, with mechanical and with architecture, both of the softwares also have hatching involved, rendering involved. Architecture and mechanical are 2D and 3D platforms. But when it comes to civil engineering basically uses Civil 3D. Now, the 3D in civil engineering, you can make maps. You have DTM, which is digital terrain modeling. In other words, you can actually take a road from 2D and create a 3D model of it. It's a lot of simulation. But now with civil, for the most part, everything is 2D. Contractors don't work in 3D. Now, 3D is good when you're doing estimation. This is what you utilize building information modeling for. But when it comes to civil engineering and surveying, basically the software is used for terrain, developing land, placing points, creating topographical maps. A software that civils also use is Carlson. Carlson is a cheaper version of Land Development Desktop. Now, Land Development Desktop became Civil 3D. But when you deal with architecture, engineering, and construction, because I'm moving over to construction right now, construction has its own software. There used to be a software called SureTrack that was estimating software. Oracle now has project management software. The big one out here is Microsoft Project. Microsoft Project is very good because Microsoft Project, if you're starting out, you're doing one project, Microsoft is very friendly. Now, a software that Oracle has, can't remember it right off the top of my tongue, but it'll come to me probably in another video. Primavera, that's the name of it. That's by Oracle. Primavera can do many projects at one time. It's more expensive than Microsoft Office, but it does the job. But there's a learning curve with Primavera. And the reason why there's a learning curve, because there's so much that goes into using the software. Now, let me back up off the software a moment and give you an understanding. Before you go into the software, you should sketch out your information on paper. Because a lot of us depend on the computer to do all the work, but we don't understand what the computer is doing half the time. But if you actually plot it out on a piece of paper, that's known as the good old-fashioned way, you'll get an understanding of what the computer is doing for you. The problem with architecture, engineering, and construction today is we focus solely on computers. Technology makes everything quicker, but it doesn't mean quicker is better. You still have to check your work. Basically, the software that we utilize, whether it's in CAD or we use Primavera, the software basically generates a presentation for the client. The client likes a good picture. But you should understand the technology, when you know how to do the calculations. Yes, the technology is always going to be there. And again, you should understand the technology, but you need to know how to do the calculations. It's like reading a book. And you open a book up, you can read words, but you have to be able to understand the subject matter by comprehending it. The same goes for the software. A lot of software isn't friendly. If you're not computer literate, you're not going to understand it. But remember, the software is good for presentation. But you have to go through the groundwork. You have to do sketches. You have to do calculations. You have to be able to take materials and build prototypes to test to see if the material is sufficient for utilizing in building construction. But at the end of the day, you need your software. And I urge anybody who is going into design, understand the mathematical part and understand the software. Because buildings are getting more and more complex, and we need people who have the ability to solve problems. The only way you solve problems is you must understand what's going on with the software and the calculations. And that is the end of my presentation for this edition of the Mind of STEM. I just presented different software for architecture, engineering, and construction. Please like, share, and subscribe to the Mind of STEM, because on this channel, you get a daily dose of science, technology, engineering, and math. And I want to thank you all for listening. Once again, my name is Leon Jones. God bless you. You have a wonderful and blessed night.